Okay, good morning. So today we are going to talk about rational exponents. Okay, this is the beginning of chapter 8 for us. One of the things we have to do is remember what the rules of exponents are. Okay, and if we go back and remember um, from before, yeah, that looks fine. Okay, when we originally talked about exponents, we had a couple of rules. We had a rule that was like an a to the r times an a to the s. And we said when the bases are the same here, we add the exponents. Okay, and then similarly with division, right? We have an a to the r divided by a to the s. Okay, again, we subtract the exponents. Again, we check to make sure the bases are the same, right? We have a, and then we're going to have a to the r minus s. Okay. And probably the most important one for us to do today is when we have an a to the r raised to the s, well, that is equal to the a to the r times s. We can do this a little bit further, right? We can just say this is s to the, or a to the s times r, which is also equal to a to the s raised to the r. So if you have like an a to the 12th, right, that's a to the 3 times 4. So this is either a cubed raised to the 4th power or a to the 4th raised to the 3rd power. Okay, and this is going to be a really important concept as we go through the lecture today. Okay, as we do some examples. So what do I mean by a rational exponent? Okay, what I mean by a rational exponent is an exponent that's a fraction. So what if I had something like this is 25 to the 1/2. Okay, well, the 2 in the bottom here, that means the square root of 25. And I'll put a 2 here, even though you typically don't need it, okay, just to make my point about this. If we have an 8 to the 1/3, that's the cube root of 8, all right? If we have the 5th root of 32, that's equal to the 5th root of 32. Okay, so that's what this thing in the bottom means. Now, be wary, okay, be wary of this, because a negative in the exponent, right, if we had a 25 to the -2 or -1/2, that does not mean the same thing, right? That's we have to deal with the exponent first. This is the same thing as 25 raised to the -1 raised to the 1/2, because -1/2, right? We could write -1/2 as -1 times 1/2, or vice versa. It could be 1/2, right, times -1. So we have options here. We could say this is equal to 25 raised to the 1/2 raised to the -1. Okay, so however way you do that, right, let's go with the first row. That's going to be 1 over 25 raised to the 1/2, which is the square root of 1 over 25. The square root of 1 is 1, the square root of 25 is 5, and we end up with 1/5. We're going to get the same thing here, right? You take the square root of 25, you get 5. So we have 5 to the -1, which is equal to 1/5. Okay, so be really careful about what the fraction means and what about the negative means. Realize that they are telling you two different things. This is telling you to take the square root. This is saying the negative part here, that's saying to make it a reciprocal. Okay, so be really careful about how that works. All right, so a couple of things, we'll keep going with this idea here. We could talk about what happens if you try to take the square root of a negative number. Okay, what if we have like a -4 in here? Well, you have to think of two numbers that when they multiply by themselves come up to -4, and -2 times -2, that ain't gonna work, and 2 times 2, that's 4. Now, later on in the class, we will talk about complex numbers, and we will have a complex number that does this. But for now, or if you're dealing with a class that only deals with real numbers, then this just has no real solution. Okay, there is a complex solution, but we're not we're not delving into that realm just yet. Okay, so if you're only restricting yourself to real numbers, this doesn't have a solution, and that's what you just say. There's no real solution here. Okay, it is possible, but we're not going to do that yet. Conversely, though, for cube roots, right? What if I wanted to get the cube root, right, of -8? Well, what this is saying is, can you think of three numbers when you multiply the number, a number when you multiply it by itself 3 times, can you get a -8? And with cube roots, with all odd roots actually, sure, that's possible, because -2 times -2, that's +4 times another -2, that's a -8. So if you're looking at, if you're looking at, say, an a to the 1 over n, okay, and we'll go ahead and say, you know, if a is less than 0, okay, you have no real solution if n is even, okay. However, you do have a regular solution, okay. You can have a real solution, okay, if n is odd, okay. So if we have a cube root of -8, the fifth root of -32, the fourth root of -81, okay. Actually, the fourth root isn't going to work because it's not odd. We need fifth, seventh, ninth, 11th, that kind of thing. Okay, so we need odd numbers in here in order to have a root. Okay, if you try to take the square root or a fourth root or a sixth root of a negative number, then your answer is going to be no real solution, because we don't have real numbers that do that. Okay, let me draw a distinction for you, because a lot of times people will talk about the square root of 25. We just call that 5. We're looking for what's called the principal square root. Okay, and a lot of times people say, but in high school I learned it was plus or minus. Like, well, it can be, but there's a slightly different context to it. If I tell you that x squared equals 25, okay, or um, we want, we put another equation in here, okay, 5 is equal, or not 5, we want, so I'm going to take the square root of both sides here. Then we're just going to get an x, but you could have, right, it could be it could be a plus or a minus in here. Okay, so in this case, if there's an equation, you want to deal with a plus or a minus. But if they just ask you, like, what's the square root of 36, your answer is going to be 6. Okay, if there's an x equals the square root of 30, then it could be a plus or a minus. Okay, so if it's unknown, we could do that. But you generally, if they're just asking you square roots of numbers, all they really want to know is what's the principal square root. Okay, so if you're solving an equation, yeah, there's 2 solutions, and we'll get to that. Okay, we'll definitely get to that. Okay, so back at the beginning, we talked about the fact that a to the r raised to the s was equal to a to the s raised to the r. Okay, that's an s, not a 5. And that becomes important when we have numbers like, well, what's, like, say 125 to the 4/3? Okay, well, we can break this down. This is 125 raised to the 1/3 power raised to the 4th, or we could do 125 raised to the 4th power and then take the cube root. Okay, this way is usually a lot easier because smaller numbers are easier to work with. Okay, but we'll use the calculator off to the side in a moment here. But the cube root of 125 is going to be 5, and then 5 raised to the 4th power is going to be 625. Just in case they don't give you convenient numbers, or maybe you don't know the cube root or the 5 raised to the 4th power off the top of your head, okay, like a normal person, how would you put that in your calculator? Okay, and let's go ahead and take a look at that. So we're going to have the 125, okay, and then we're going to use this caret button. Okay, Now, this is really important when you have a rational exponent, because if I just type in this, what the calculator thinks I meant is take 125 raised to the fourth power and then divide this whole thing by 3, because in the calculator's processing, exponents come before division. Okay, so even though you meant raised to the fourth third power, the calculator thinks you meant 125 raised to the fourth, and then take the whole thing and divide it by 3. So what the calculator thinks you're doing is 125 raised to the fourth divided by 3. So you got to be real careful with that. And I'll type in the enter button. I know you're breathlessly waiting for that answer. But that's not what we want. Okay, what we want is the 125 raised to, and you have to use parentheses with this, otherwise it's not going to work. I urge you to leave it as a fraction unless it's something that's very reducible to a decimal. Like if you're doing 1/2 and you type in 0.5, it's going to be the same thing. We'll show you an example of that in a moment, but here we are. We get 625. This was the expected answer. So let's go ahead and just, let's go ahead and try this. So if I went 16, say the square root of 16, we know that's going to be 4. And I wanted to do it with fractions. We could do 1 divided by 2. Okay, and we're going to get a 4 there. We could also do 16 raised to. Now you don't need parentheses if you're going to convert to a decimal, because there's no other operation going on here. Okay, so this would just be 16 to the 0.5, and we're still going to get 4. So either way you enter that in your calculator, that's going to be fine. But generally, the more complicated of an exponent you have, the more you're going to need to use those parentheses in there to make sure that you're going to be getting the right answer. Okay, so just be really careful about that. If you wanted to figure out like what would be 16 to the negative 1/2. Okay, well we know that this is going to be 1 over 16. Take the square root of it, right? Because the 2 here says take the square root. The negative says take the reciprocal. We could do that in one breath, and then we're going to get a 1/4. If we try in the calculator for that, okay, again, we do 16 caret negative 1 times 1/2. What do you think we're going to get? Right? We're going to get 1 over 8. Okay, so that's not going to work out so well. Okay, um, yeah, 16. Yeah. So if we end up doing this correctly, right? Caret and then negative 1 divided by 2. This is going to give us our 0.25. Okay, so that's how you want to go through and do something like this. All right, so just be really careful about parentheses, and make sure that we're working with this correctly. Okay, so all right. Let's see here. I don't want to do that just yet. Oh, we could graph a couple of these things. Okay, we can make a little t-test, or t-table rather. We could talk about graphing rational functions. All right, and oh, not rational, radical. Okay, so when you move on to college algebra, this is going to be kind of important. What you're looking for are nice numbers to give to it, nice numbers to make a function to come up with nice answers. So what if we have a g of t is equal to the fourth root, okay, of say t minus 2, okay? This week we could also represent this as t minus 2 raised to the 1/4 power. This means the same thing. And we'll make a little table here, okay? So we can't take the fourth root, right, of negative numbers. So the smallest number I could put in for my t, right, is 2. Because can you think of can you think of a number when multiplied itself 4 times, can you get 0? Sure. That's going to be the fourth root. We're going to say, well, let's go ahead over here. We're going to get 2 minus 2. take the fourth root of that. That's going to be the fourth root of 0. 0 times 0 times 0 times 0, that's equal to 0. So the fourth root of 0 is 0. What if I plug in 3? Okay, then we're going to get the fourth root, right, of 3 minus 2. That's equal to 1. Okay, and can you think of a number when you multiply it by itself 4 times, you get 1? Sure, that's what the fourth root means. So we end up with a 1 there. Now, if I plug in the next number up, all right, this is not going to be a pleasant integer value for an answer, okay? We're going to get the fourth root of 4 minus 2. We're going to get the fourth root of 2. Can you think of a number when you multiply it by itself 4 times, you end up with 2? So if you answer 2, like, no, that ain't going to do it because you get 2 times 2 times 2 times 2, that's 16. That's not helpful. So it's got to be a fraction. And that is not going to be an easy number to figure out, which is why we invented these things. Okay, so let's go ahead and look at what that number could be. Okay, and we end up with this goes on and on and on forever. Okay, this is an irrational number, and it just keeps going. So that's not we can approximate it, and I'll write down a decimal place, but that's not an exact answer. 1.8927, and it keeps going. Really what you want to do is you want to pick numbers in here that do have a fourth root. So I know 0 and 1 do. I think the next number that has an easy fourth root is 16. So how can I make this guy here 16? Okay, well, if I make t equal to 18, okay, 18 minus 2, okay, 18 minus 2 is going to give us 16, and the fourth root of 16 is equal to 2. 2 times, we just did that up there. So here's our 2. Okay, and it's going to get really big really fast in order to do this. Okay, this curve flattens out a lot real fast. Okay, so if I wanted to go ahead and make a little graph here, right, here's my t, here's my g of t. It's still y if you want to call that y. I'm not gonna argue with you. But here's 1, 2, and at that point we have a 0. At 3, we're up to 1. Okay, and then I've got to crawl all the way out here. This is not the scale. I'm sorry. I kind of was in a hurry to write all of that out, so I was not careful about scaling this. But it would probably be off the page by the time I got there. But this would be 2. So my graph is going to look, and this does continuously crawl up. Okay, I think if we wanted to get the next one for 3, let's see. I think we need to get 81. So I think the next one is going to be 83 here. 83 minus 2 is 81, and a fourth root of 81 is 3. So we got to crawl all the way out somewhere beyond, way beyond my screen in order to get up to 3. So this does keep increasing despite the way I've drawn it, but it's very, very slow. Okay. So that's the way you want to do this. If you're not going to be good at this at first, it takes some practice to pick numbers, especially with fourth roots or with 3/2 roots or things like that, to pick numbers where they're going to come out nice. So if you plugged in 5, right, we're going to do 5 minus 2. That's going to be 3. So we're going to do, you can even do it this way. Okay, how about we do this? We'd be really lazy. We do 5 minus 2, parentheses, caret 2 to the 1/4 power. And what's going to happen here is it's going to do 5 minus 2 first in the parentheses. It's going to give us a 3 raised to the 1/4 power. So we're going to end up with like a, if we put in 5 here, we get 1.316. So you have the calculator available to you, so you don't have to be that proficient in picking out these numbers, or that lucky for some of us, me included, for picking out some numbers that give you nice answers. Okay, you have this. I just urge you to remember These are not exact. They're rounded to however many decimals you want. They actually keep going on and on and on. There are an infinite number of values here. But that's how you would go through and graph this. And if you're going to do the smaller numbers, I would urge you make a better scale. Okay, I would definitely think about mapping this out a little bit more carefully. Okay, so that's how you graph these things. We'll talk about domains in a little bit. Actually, we'll talk about domains now. So they want to know, what's the domain of a function? What are the legal values of the argument? What are the values of the argument that are going to give you an actual number, even if it's ugly, when you evaluate it? So let's go here and we'll look at our g of t is equal to the fourth root of t minus 2. Okay, I'm sorry for my handwriting. This is awful. So we're going to look at the fourth root of t minus 2. Well, it's a fourth root, right? My n is even. This is t minus 2 raised to the 1/4. The n here is even. So this thing has to be a positive number. So if I put in a 0, right, if t is equal to 0, 0 minus 2 raised to the 1/4 power, we're not going to get a real answer. Okay, I would urge you to plug this in your calculator. So negative 2 raised to the, oops, not raised, not that one. Go back. Raised to the 1/4 power. Hopefully the calculator isn't smarter than I am. And good, it gave me a non-real answer, and we'll go ahead and go back to that. If we change this back to a positive number, that would work out. Okay, so we're going to go ahead and we have to figure out, where can t be positive. Okay, and the algebraic way of asking that is saying something like t minus 2 has to be greater than or equal to 0. Okay, I know we did these like at the beginning of the semester, and I know you have perfect recall from 10 weeks ago, right? Everybody does. So my restriction on my domain is t has to be greater than or equal to 2. And they're going to say, write this in interval notation. So t can actually be 2. So we get a square bracket because it can be equal to it. And then any number that's bigger than 2 is just fine. Okay, so we're just going to do a lazy 8, and then you always write a parentheses on infinity, because if you're in a bracket, that tells me that you've been there. And as my office mate will say, please take a picture and show me, because I don't know what that looks like. Okay. What if they do something weird to you, like they do g of t is equal to the fourth root of t minus 2, and they add some kind of a constant on here. They say, they subtract, well, say minus 5. Well, the pressing issue here is making this radical a positive number. The minus 5 we don't really care about for the domain. It's not influencing our pick for t at all. Our t is entirely picked because of what's going to happen inside the radical. Okay, so here's where you want to make sure that you're picking a positive number that you can take the fourth root of. And then if we end up with a negative 5, that's fine. That's just going to move it. That's just going to move it down here a little bit. So it's okay for the graph to be under the axis. It's not okay for the t part, right, to be under the axis. Okay, and this depends on the problem that you have. So it can change a little bit. All right, we could we could do a g of t. Let's actually do a couple of problems. So if we do an f of x is equal to the square root of 2x minus 7. Okay, what we want to have happen is we need this 2x minus 7 to be greater than or equal to 0. Okay, this is probably a question I could have asked you on day 1 of the class. So x is greater than or equal to 7 halves. If I put 7 halves in here, we end up with a 0. You can take the square root of 0, that's okay. So again, they'll say put an interval notation. Since I know that 7 halves is the smallest number I can have, we're going to put a bracket here because this equality says you can have a bracket, and then all the way up out to infinity. Okay, let's look at a different one. Let's look at an h of x. Okay, and I'm going to turn this one around on us, and that's going to be 3 minus 4x. Okay, so wait, I thought you couldn't have a negative number. You can't. But if x were a negative 1, then we'd have 3 minus a negative times a negative, that would be a plus, and then we'd end up with a positive number in here again, okay? So we're still going to follow the same algorithm. We're going to say, well, whatever's inside the radical here, that has to be greater than or equal to 0. If we subtract 3 from both sides, we get negative 4x greater than or equal to negative 3. And then I want to divide both sides, or I want to multiply both sides by a negative quarter, right? That's going to cancel out my 4's. But what's the rule when I multiply across an inequality with a negative sign? And the rule is you got to flip the sign. Okay, so in this case, x could be any number smaller than 3/4. Okay, so in this case, the 3/4 goes on the right, and it could be any number smaller than that, right? If I put in a -1 here, that's fine. A -2, -4 times -2 is 8, and 3 plus 8 is going to be 11. Again, not the prettiest number in the world, but square root of 11 is just fine as an answer, and that's how you do these. So be careful about this, okay? In my classes, I always ask a question where you have to remember how to do this, and quite frankly, it, it I know it's a rough question for you, which is why I asked this, okay? So what about if I do a j of x, okay? And we'll make this equal to the cube root of 2 minus x, okay? Well, remember cube roots, if I take the cube root of, if I put 10 in here, right, I have 2 minus, so if I say x equal 10, okay, then I have the cube root of 2 minus 10, which is the cube root of -8. And we talked about this way on the first page. This was just fine. So when they ask you about the cube root, your domain for j of x, like, I don't care what x values are, I'll take the cube root of a negative number, that's fine. So it's kind of a trick question where they pretty much give you, well, it's all the numbers, okay? You only have to be worried if this radical is going to be an even radical, if it's going to be a square root, a fourth root, a sixth root, an eighth root, dot, 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 dot. If it's 3, 5, 7, 9, if it's an odd number, then it's really just a trick question. They're asking you, can you identify it's an odd number, and do you know what to do about that? Okay, so be careful about that. But don't. It's an easy question not to get tricked on. Okay, so don't do that. Let's see here. I think we have one more thing to worry about, really, and that's Pythagorean's theorem. Okay, so one of the pitfalls. Okay, one of the pitfalls with something like this. Okay, so this. Okay, let me start from an easier source. Right, we got c squared equal to a squared plus b squared. C would be the square root of a squared plus b squared. That's where we're coming from. Okay, this is how to find the hypotenuse of a triangle if you have two sides. Or right triangle. Okay, well, not non-right triangles, you get to a trig. So you can't, okay, you could simplify this. You cannot distribute that. Okay, that is a giant, you cannot do this. Okay, I used to have a teacher that would take off more points than the problem was worth if he thought you made a stupid mistake. This is one of those times where I would be tempted, like, if this problem was worth 2 points, I would be very tempted to take off 4. Okay, it's so bad of a mistake. The people that's sitting around you, they lose points because this was so awful. Okay, so it is not a plus b. Okay, you can't go through and do that. Okay, you have to go through and square and square. So if we take, this is every carpenter's favorite triangle. Okay, this is every engineer's favorite triangle. Okay, we have a side of 3, we have a side of 4, and if you've ever heard of a 3, 4, 5 triangle, this is what they are referring to. Okay, so hopefully this does not get me in trouble with YouTube too much. What you're doing is, if you're saying that this value here, okay, if you're saying that c is equal to the square root of a squared plus b squared, which is just equal to a plus b, what you're saying to me is that this side plus this side is equal to cutting through. And I think every little kid that's ever cut across a lawn has realized that walking all the way around the corner is going to take longer than cutting through somebody's yard, provided they don't have a dog. Okay, so if you cut across a field, that's obviously going to be a faster way through. That's going to be a shorter way, rather than taking the whole corner around this. Okay, um, I usually try to do something. It's a terrible. On the blackboard, my dogs are terrible. Okay, but if you're running for your life from a pack of wild dogs, or maybe a pack of wild brontosauruses, or whatever this looks like to you, and you say, you know what, I've made this mistake in the past and I wasn't taken off for it, so I'm going to run all the way around here. Well, this pack of dogs is not going to chase you like this. This pack of dogs is going to go through and make a cut. Okay, and they are going to catch you, and you're going to be somebody's lunch. Uh, if you do this on an exam or a quiz, you're going to be somebody's lunch. Okay, please don't make this mistake. It's the easiest one not to make. So just to go through and demonstrate numerically, right? That's equal to 9 plus 16, which is equal to 25, which is equal to 5. If we do it the other way and say this is 3 squared plus 4 squared, that's equal to 3 plus 4. Um, those are two different numbers, right? I would rather have $7 than $5, but if I'm running for my life from a pack of wild dogs, I would rather have to only run 5 meters or 5 whatevers, rather than sevens, because I know I can't run that fast for that far, at least not faster than dogs, so we don't want to do that. Okay. So I'm going to go ahead and leave you there. You should have enough there to at least start your homework, and we'll continue on with slightly more interesting problems, or slightly more difficult problems a little bit later. I apologize. There's a lot of problems in the homeworks for these sections, mostly because they're just getting you used to the arithmetic and writing out the different ways of writing the radicals and the different rational exponents. Okay, so thank you and good luck with your homework. All right, so we're gonna stop recording.